And then with that, we will hand it over to Ryan Hlettick, principal at the Brattle Group, and Tony Lee, a consultant at Brattle. Ryan and Tony.
Great. Thank you, Charles. It's a pleasure to be here with everyone. This is Ryan Hlettick. I'm a principal in Brattle's San Francisco office. For those of you who aren't familiar with the Brattle Group, we're an economic consulting firm. We're headquartered out of Boston, Massachusetts, and have offices around the US and internationally. And I'm a member of our energy practice, and our energy practice is focused on a pretty wide range of issues, with a particular focus on electricity. And that includes issues from the wholesale level related to wholesale market design, ranging all the way down to the retail level, and issues associated with rate design, resource planning, and a variety of different topics like that. So my focus personally has really throughout my consulting career been on the grid edge and issues that relate to the energy customer. And in particular, two areas that I've been focused on recently are demand response and load flexibility, and also electric vehicles and electrification of the power system more broadly. So those two topics merge really nicely into what we are focusing on today, which is demand response for electric vehicle charging or electric vehicle managed charging. So I am joined by my colleague, Tony Lee, who's also a consultant in our San Francisco office. I'm going to lead the presentation, and then he will be chiming in with answers during the Q&A portion of the presentation. So we can jump to great. Thank you, Charles. So as the first presentation today, we thought we would just try and basically tee up some of the big questions around managed charging, share some of Brattle's insights in these areas based on the research that we've been doing, and then hopefully just sort of create a common understanding of these issues for everyone, so that when we hear the Avista and EPRI presentations that follow, we'll all have some context for that discussion. So the first big question is why take time to think about EV managed charging? What's the reason for doing that? The big reason is unmanaged EV charging has the potential to be very expensive. We have a report that's going to be coming out probably in about the next month or so that will be focused on the infrastructure requirements associated with supporting a significant number of electric vehicles coming on the road in the future. And what we find at a very high level is, having 20 million electric vehicles on the road by 2030, which is kind of the low middle end of the range of a pretty wide range of electric vehicle adoption forecasts that are out there. 20 million EVs by 2030 could require at least $100 billion in infrastructure investment, if not more. And the reason for that is electric vehicle charging load, whether that's happening at home on a level 1 or a level 2 charger, or happening at public charging stations, is going to lead to a need for more power generation capacity, more T&D capacity, and also a significant amount of installation of hardware for the customer in terms of charging infrastructures at the home or the apartment building or the office building. So left unmanaged, that's a pretty big price tag, and what managed charging allows us to do is to manage that charging load in a way that we can hopefully mitigate some of those investment costs. If we can do that, customers will benefit. It'll reduce charging costs for customers with EVs. Managing customers' charging load can also help to streamline charger installations, particularly where there are capacity constraints at the customer site. And then the environment also potentially stands to benefit from managed charging as well, particularly if we can shift charging load away from those hours when we have higher emitting resources that are running, dirty power plants, and shift that load potentially to hours when we're actually curtailing renewables that are producing carbon-free power. So those are a few just sort of high-level reasons for why we're interested in this. And then I think the big question that comes up regularly when we start to talk about the potential benefits of managed charging is, why talk about this now? There are roughly 1.5 million EVs on the road. That's less than a percent, I think less than 0.5% of all cars that are on the road today. So why is this something that we need to worry about now? One reason is technological disruption can happen pretty quickly. And what we've seen, electric vehicles they're part car and they are part, software-based disruptive technology. And what we've seen as we've reviewed a range of technology adoption rates around the US is, there often is not a nice, predictable, linear progression toward technology development. What we typically see is that we have some early adopters of the technology who adopt it out of interest. And then at some point, there becomes this inflection point where things really take off and we start to see adoption of these technologies hitting the mass market and large numbers of customers then basically getting on board and adopting them. The data that we had to put together the chart that you're seeing on this slide is a little rough, but I think just historically what we've tended to see is that inflection point can often happen maybe around the 10 to 20% adoption rate for these given technologies. And in spite of there only being 1.5 million EVs on the road today, there are parts of the US where we're actually already starting to creep into that 20% market share range. I live in the Bay Area and Santa Clara County, which is one of the counties, basically south of San Francisco on the San Francisco Peninsula. Based on the latest data I had seen in 2018, had reached electric vehicles having more than a 20% share of all vehicles sold in that year. So that's Santa Clara County. Of course, San Francisco and California have been ahead of the curve in terms of EV adoption from a national standpoint. But it's just interesting to see that we are already today in some select parts of the US reaching the point where we are, potentially on the significantly upward sloping trajectory of that adoption curve. So this EV adoption is something that could potentially come more quickly than we realize. In addition to that, I think on the next slide, it's also helpful to just think qualitatively about some of the reasons why customers might be interested in an EV versus a conventional internal combustion engine vehicle. So some of the advantages of electric vehicles, lower fuel costs. Electricity costs less than gasoline to put into your car. Maintenance requirements are minimal because the drivetrain of an EV is very simple. They're clean, good for the environment, quiet and fun to drive. I think anyone who has been behind the wheel of a Tesla can probably attest to that. And with EVs, you have the option to fuel them at home. All of these, and this is just basically my brainstorming list, so I'm sure people can come up with other thoughts as well, but all of these are really permanent advantages that electric vehicles have over internal combustion engine vehicles. The advantages of internal combustion engine vehicles, in other words, the reason that we're today only at a point where less than 1% of customers have an EV, are a lower upfront purchase price. I think even with subsidies, it's still pretty easy to find a conventional ICE vehicle that costs less on an upfront basis than an electric vehicle. Dependable fueling infrastructure, no range anxiety, where the gas stations are, what the typical mileage is of your vehicle, so that's not a concern. Customers have confidence in a reliable, proven technology rather than maybe some fear of the unknown associated with driving an electric vehicle. And then finally, there's just much more diverse model availability with internal combustion engine vehicles. So those are some of the reasons that customers are sticking with ICE vehicles today. But I think the question we need to ask ourselves from a timing standpoint is, how long will these advantages last? The cost of batteries is coming down on a monthly basis. So that lower upfront purchase price advantage that ICE vehicles have is eroding quickly. Charging infrastructure is being deployed, at least in certain parts of the country, on a pretty dense basis. So customers are starting to overcome range anxiety. The range of batteries is getting broader. And generally, the more time people spend with EVs, the more confidence they're starting to have in this as a reliable technology. Finally, I don't know if Dan Bowermaster will mention the specific statistic in his presentation, but what we are also seeing is within the next, I believe, year or two, there is expected to be just an absolute explosion in terms of the number of electric vehicle models that will become available. And so, concerns about not being able to get an electric version of an F-150 or crossover SUVs, those sorts of barriers are quickly going to start to be erased as manufacturers shift at least some of their focus toward putting EVs out as well. So just interesting to think about the fact that, the reasons the customers may not be buying EVs yet, those are reasons that likely will not last forever. Okay, so those are just a couple slides on, why we're talking about this now, and then we've put together a few slides just to, I think, try and bring everyone together on the same page about what we're really talking about when we talk about managed charging. Really, there are two categories, which I suspect most of you are familiar with, given that this working group's focused on electric vehicles. The first is active managed charging, and that is really when we say active managed charging, what we're talking about there is managing the charging of an electric vehicle through remote control of that vehicle's charging. So this is the equivalent of direct load control programs that you've seen with air conditioners, et cetera. On the passive managed side there, we're talking about rate designs and more behavioral types of customer response. So what are the advantages of active versus passive managed charging? With active managed charging, you have more flexibility and precision in your ability to manage that charging load. That can happen in real time, and it allows you basically to control a whole portfolio of chargers across the system in a very sophisticated way. And really that precision and that flexibility and control, what that allows is for those programs to provide more value by providing a wider variety of grid services, whether that's avoiding the system peak, reducing local distribution peaks, or potentially even providing ancillary services. On the passive managed charging side, costs are lower. Rolling out a time of use rate is certainly cheaper than rolling out technology for automated control of a charger. It, depending on how you define it, potentially leaves some more control up to the customer. They can simply choose to pay the higher price at the time of use rate if they want. And then lastly, we have a lot of experience as an industry with time of use rates, and I think including time of use rates for electric vehicles. So there's a little more certainty there when we start to roll out these programs as to how we'll overcome some of the implementation challenges, as well as what we might expect to see from customers once they're enrolled in those programs. So active versus passive managed charging, what is the current landscape? We've definitely seen more activity to date with passive managed charging programs. The map on the right of this slide shows you the states that are offering basically time varying rates that are specifically for customers with electric vehicles, and the percent of customers in a given state that have access to one of those rates. So what we've seen is across the United States, roughly a quarter of customers have access to one of those rates if they have an electric vehicle and choose to enroll. The map on the left shows experience, at least that Brattle was able to identify through its research, with active managed charging. And really what we're looking at there are a few pilots on the West Coast that have really just started to answer some of the initial questions that we have about how effective these active managed charging programs can be in terms of shifting load to times when it's needed, and what some of those benefits might actually be, whether that's reducing transmission and distribution costs or potentially shifting load to hours when you're curtailing renewables and clean energy generation. So I won't spend time in this presentation talking about the specifics of those pilots. I think we'll hear from Avista and get a lot of really interesting information from their experience. But what this slide really does, I think, is just kind of highlights the fact that, as an industry to date, we have significantly more progress on the passive managed charging side, particularly with time of use rates, than we do yet on active managed charging. And there's probably a good reason for that. I mean, as we've done some work with SEPA on this topic, and one of the things that we've thought of is, time of use rates for electric vehicles, those, given the lower cost of deployment and the fact that they are pretty good at shifting load to those off-peak hours when you want customers to be charging their vehicles, those are potentially the right option at relatively low levels of electric vehicle deployment, because they are effective, and they don't require, and at low levels of EV deployment or adoption, you don't have some of the same needs that we'll have at higher levels of adoption associated with really smoothing out the load across a lot of different cars that are plugged into the grid, and potentially needing to be managed in more sophisticated ways to make sure that that load profile sort of aligns with the system's capabilities. So this is partly a matter of timing and starting with time of use rates, and then potentially transitioning toward active managed charging when it's needed. So what should happen next? We have two thoughts, particularly as it relates to active managed charging, given that we have relatively less experience in that area. The first is, utility-specific load flexibility potential studies can help to answer in detail a lot of the questions that we have about the potential value of these programs, their potential impacts on the system, and particularly, which we'll talk about in our last slide, the different options for managing charging and the right way to do that given a specific utility system need. Not every utility is going to have the same needs or the same benefits from EV managed charging. And so some studies that are tailored to a utility system and really look specifically at that utility's costs and their conditions and their forecast of EV deployment, that is really the first step in making a decision about whether or how to move forward with any type of EV managed charging program. Once that type of study has been done and we've said, okay, I think we know the type of program that we want to roll out, the one that makes the most sense for our system and our customers, then really the next step is, I think, particularly when we're talking about active managed charging, a pilot. And I've been doing consulting work, particularly related to rate design and smart metering and dynamic pricing for about 15 years now. And I've become hesitant to recommend pilots as the next step, because I think sometimes they can just basically act to delay the deployment of what is otherwise a really good idea on a full-scale basis. But I think, given where we are with EV adoption, and the fact that today there is not, at least in most locations, that pressing need for active managed charging, this really feels like the right time for us to be figuring out how that technology works, what customers like about those programs, and doing this on a pilot basis so that when we do hit that inflection point and EV adoption really takes off, that we will be ready for that and able to move toward full-scale deployment of these programs pretty quickly. So that, I think, is, I suspect I'm about out of time. That is really kind of the key takeaway, I think, from our standpoint as to where we are today. We have a slide here that I'll just spend 30 seconds on that is derived from some work that we did for utility in the upper Midwest. And what I just want to highlight here is this blue line is the aggregate charging profile for a bunch of EVs that would potentially be on a utility system. And what we were focused with this utility in particular initially was understanding the potential that a managed charging program could have for reducing their system peak and reducing their need for new generating capacity. And what we found was, again, for this utility and for their system conditions, that during that 4 to 5 p.m. time window when their system was peaking, there actually wasn't expected to be a ton of electric vehicle charging load. So EVs weren't going to be making a dramatic contribution to those peak capacity costs. But as EVs returned home from a day at work and all started to plug in and charge later in the evening, and that EV charging load reached its peak, there is potentially, if electric vehicles are adopted in a geographically clustered way, the potential to lead to very significant distribution capacity cost increases, even if those EVs aren't adopted on a widespread basis across the system. So the conclusion from this specific study was, this is not necessarily a near-term problem for the system as a whole, but it is potentially a program that could be very valuable if deployed on a sort of locational basis in areas where that distribution system is going to start to hit its capacity limits. This is just intended to highlight some of the value in those utility-specific types of assessments of these managed charging programs. So I will stop there. We have another slide that just highlights some of the work that we've been doing in this area with EPRI and SEPA and EEI and others. Happy to share any of the research. I think all the research on this that I'm showing on this slide is public. So feel free to drop us a line if you have any further questions. And if there's time, I'm happy to answer questions now or save it for the end. Charles, I'll turn it back over to you.
Thank you so much, Ryan. So we have gotten a few questions. If you have additional questions, feel free to either raise your hand using the raise hand function, or if you'd rather not speak, then send it in the question box. So let's see, Danielle, do we have any questions you have ready? Or I can pull one up, let's see. Okay, so a question for Ryan. Can you comment on the potential availability of a larger range of EV vehicle models given coronavirus and associated economic impact?
That's a great question. I mean, I can't, that might be something that the folks at EPRI have been thinking about, not to put Dan on the spot for his presentation. You know, all I can really say at this point, given how new the situation is to everyone, is I've probably seen the same headlines that you all have around concerns about what coronavirus and its economic impacts could mean for adoption of electric vehicles. I think a lot of what I've seen is more concern about consumer interest in going out and spending money on a new car than it is necessarily concern about the OEM's commitment to rolling out those models. But just to be honest, I don't have a lot of insight as to the extent to which their timeline for introducing models could be affected by coronavirus. I imagine things could be delayed, whether a manufacturer would decide to reverse its decision to introduce a new model that's been in the works. That seems less likely to me, but that really is just my speculation.
Great, thank you. Next question, are there more details about the utility-specific study mentioned on slide 13? Is that available?
So we can definitely share a couple of load flexibility studies that we have released recently. Those load flexibility studies will go beyond just managed charging for electric vehicles and will actually include information on analysis that we've done of the load flexibility associated with a range of end uses, which includes EVs, but also includes residential air conditioning through smart thermostats and automated demand response for buildings, and other opportunities like that for basically using load as a tool to help to integrate renewables and transition toward decarbonization. I think that the slide that I was presenting previously was somewhat anonymized because I think that very specific analysis wasn't public, but I'm more than happy to share some of our load flexibility studies, which get into a lot of those same dynamics that we were presenting there.
Great, thank you. Commissioner Bocanegra, do you have other questions?
Hi, Charles, can you guys hear me?
Yes, we can.
Yes.
Okay, great. I was having connection issues. I think there was a question earlier, but we'll go ahead and publish it. I think someone was asking, and maybe this was the one they were referring to, whether you guys can release the actual report. They didn't specify the load study you were just mentioning.
That may have come up at the beginning when I was referring to some of the work we've been doing on the cost, the infrastructure cost of EV adoption. And that, yeah, we definitely, I will make sure to get Charles and others in the loop when that's released so that you can distribute that to everyone, because that will be public and we're more than happy to share it.
That would be great. And I think I will ask you one more question before we move on to our next speaker, just to be conscious of time. In the beginning, your slide mentioned that there was expected 20 million EVs by 2030, an estimated cost of $100 billion. And this might be answered in your report, but can you talk a little bit about what the potential avoided costs are with something like managed charging?
Yeah, no, that's a very good question. And I think we will try and highlight some of that in the report. It's hard to put too specific of a number on this, just because it tends to be, you know, a utility specific number. Every utility is facing its own distribution costs and system costs, so it varies. If I'm remembering correctly, a rule of thumb that was coming out of some of that analysis was that managed charging, the ability to manage load and reduce some of those costs was pretty material in terms of, say, amounting to maybe 10 to 20% or more of the 100 billion plus of investment that would be needed. I mean, generally what we've seen is that electric vehicle load tends to be very responsive to time of use rates or to active managed charging, meaning it's a very flexible load that really can be shifted to those lower cost hours, and that can lead to pretty, even compared to a conventional demand response program, pretty significant cost avoidance when customers participate. So I think that kind of the takeaway is, if we can get customers enrolled, then there is a pretty material portion of that $100 billion that can be avoided through managed charging programs.
Thanks, Ryan. I have another question that came in. It is, any suggestion on addressing the night peak by EVs without having to do system upgrades?
Without having to do system upgrades. So that, you know, I kind of mentioned maybe at the beginning that through some of the work that we had been doing with SEPA previously, we had kind of come to this conclusion that time of use rates are a good, say, more near-term load management option when adoption is low. But one of the challenges with time of use rates in particular is, you know, let's say that the off-peak lower price period of a time of use rate for EVs starts at 11 p.m. or midnight. Customers who are responding to that rate will all have their electric vehicle set probably to start charging at 12:01 when that lower price kicks in. At low adoption levels, that's probably okay because you've shifted that load to the middle of the night. But if suddenly you have several customers on a given block who have an electric vehicle with a level 2 charger that's turning on at that time, you can create a new significant peak on your distribution system that could be pretty costly. And so that's where we see there then becoming a role or a need for active managed charging, because active managed charging then gives you the ability to manage the charging of each of those EVs on that block individually and basically stagger the charging in such a way that you ramp up more slowly and in a more sophisticated manner can manage that load across the distribution system. So I don't know if that answers the question, but we do see active managed charging as being one of the key solutions to that problem.
Thank you, Ryan.
Great. So sorry if we didn't get to your question. There will be an additional few minutes for questions at the end of all three presentations, so hopefully you can ask it then. But just in interest of time, moving on to the next presenter, Mike Rivera from Avista.
All right, thanks, Charles, and thank you everyone for inviting me today. So I'm Mike Rivera. I'm an engineer at Avista Utilities, where I've been working on transportation electrification projects for the last 4 years. So today I'm just going to talk about our EVSE-based managed charging program that we ran as part of our EV charging pilot project from 2016 to 2019. So you can go to the next slide. So Avista, this is just a picture of our service territory. We're a fully integrated utility. We're based out of Spokane, Washington. We have both electric and gas service in Eastern Washington, North Idaho, and then we have gas service down in Oregon and a subsidiary in Alaska. So we have roughly 350,000 of both gas and electric customers, and service territory is largely rural here, with the exception of the Spokane area. So we have a pretty big truck culture. As a result of that, EV adoption is quite a bit lower than the west side of the state where Seattle's at. But actually over the last couple of years, we've actually had above average EV sales in our service territory, mostly clustered in parts of Spokane. So this is just an overview of our EV charging pilot that we ran. When we started the pilot, one objective was just to build out infrastructure to support development of EV charging. We also just really wanted to increase our knowledge of the charging industry from a technical standpoint, understand drivers' habits, behaviors, and be able to figure out how the utility fit in to support and in some cases seed the charging infrastructure needed out there, as well as test solutions like managed charging. So this pilot that we set up was fairly comprehensive. It involved utility-owned residential and commercial level 2 stations and 7 DC fast charging stations. We also wanted to get a better idea of the differences between networked and non-networked. So, we had a mix of both of those in all the different categories except for the DC fast charging stations. So just what I'm talking about today is the DR program, which was in the bounded left box here, primarily in residential. We also had a couple locations where we did DR in commercial settings. So this chart is just a straightforward unmanaged charging session with 5-minute incremental meter data. It's just from when a driver comes home for the day. From a distribution perspective, adding this load coincident to peak household demand isn't really a big deal, if there's only one EV on the transformer. But like Ryan was saying, we've noticed there's geographic clustering of EV drivers in our region and in our program. Also, we've had multiple customers with more than one EV in their household. So we used sessions like this to actually conduct a distribution system analysis, first order analysis, where we applied EVs at half the service points of transformers in our area, and then a second scenario where we applied 100% of service points having electric vehicles. And we actually, from the first one where we applied 50% adoption, we found that 1 in 5 transformers would overload even when we applied a coincidence factor to the charging. And then at the 100% level, the failure rate increased to 1 in 3. So it's definitely something we're paying attention to, even if it's not really impacting the T&D side right now. So this is an average profile that we got from over 36,000 sessions worth of residential charging data. So we use this to create our baseline home charging profile. So just as a comparison to the last slide that showed the T&D impacts potentially from a charging session, this type of load profile really affects the overall generation capacity requirements for each incremental EV added. And you can go to the next, thanks. So going into our DR, a major goal of our residential DR testing was to really determine how much load we could shift from on-peak to off-peak while still maintaining high customer satisfaction levels. We were able to just continuously get feedback both through formal and informal channels from customers, and that really helped us adjust the program to maintain these goals. Also, we were able to do things like work with our EVSP, our software provider, to develop functionality to be able to opt out of DR events for customers just using their phone app. And then, of course, once we were able to get our profile data as well as the cost data, we were able to run that into an economic model and get a customer impact measurement, and then also figure out, the impacts on just the regional perspective costs. So I put this table together just to provide a kind of simplified overview of the current state of communications and out-of-the-box DR solutions that are available right now for utilities to connect utilities, EVSPs, charging stations, and ultimately the EV. I left out direct EV communications on this and just really focused on solutions with communications going through the charging station for right now. Although direct EV communications is something I'm very interested in and keeping a close eye on. It's worth noting here that in our pilot, we used Wi-Fi and cellular pathways for the station communications, and the DR events were set up just manually through a web portal to just run static events during certain times for certain curtailment levels daily. So there's a ton of potential here to automate and refine DR. Still a lot of development required for that, but again, that's another thing I'm monitoring and interested in testing more as solutions come out. So getting into our program, we had the goal of high customer satisfaction, so we just slowly rolled out the program to make sure we were doing it right. We experienced some slight delays in the rollout. We had things like firmware updates that needed to take place for things to work smoothly. So you can see on the chart here, ultimately we ended up with 92 customers enrolled in the program. Although due to issues really revolving around the Wi-Fi connectivity of the stations, we were only able to get reliable data from about 60 stations consistently. So go to the next. All right, and like I mentioned, residential customers in our program were able to opt out of DR events using their phone. So we were able to collect data on that. You can see on the chart on the left, 85% of customers chose to opt in, and that's pretty good considering we didn't provide any direct compensation for drivers to participate in these events. The 15% of sessions that were opted out, the customers who did it, it was only about 10% of the total customers participating, and with one driver accounting for just about half of that. So, we surveyed the customers about why they opted out, and the ones that actively opt out, the primary reason they gave was that they just really wanted to see whether the session would indeed not curtail when they did that. So we're definitely working with a more early adopter type of customer. I'm sure that'll change down the road as things get more towards the mass market, but that's our preliminary data on that. And also, I just should note, our residential DR sessions, we curtailed to 1.8 kilowatts from 4 to 8 p.m. every day. So this is an example of one of those managed sessions. You can see peak demand was reduced by about 80% until 8 p.m. when the DR event ended and the vehicle resumed charging at its maximum rate. So at the distribution level, you can see this would have a definite impact, especially in areas of high clustering of EVs. And then this chart shows our aggregated average residential DR profile in really dark blue compared to the baseline profile in red. So while we found the DR was effective, by just reducing the average demand between 4 and 8 p.m. by about 50%. You do notice the spike that's hard to miss. You know, one solution that we really ran out of time for by the time the pilot ended was just to extend that DR event from 4 to 11, and just doing some modeling on that, it would have reduced that spike by quite a bit. So it's not really that big of a deal, you know, as long as you're able to you know, extend the DR time without interrupting the customer's charging schedule, which, since the vehicle's generally plugged in until the morning, that's an option. All right. So here we have some of our aggregated commercial results from a fleet location on the left and then a work location on the right with regular EV charging. So here we ran just another simple DR curtailment between 5:30 a.m. and 10:30 p.m., where we curtailed to a max rate of 1.8 kW every day. So again, here the baseline profiles are in red, and then the blue is the DR profiles. So on the left profile at the fleet location, you can see the flattening curve. And since vehicles are plugged in overnight, we were really able to just push the usage into the overnight off-peak hours. And then on the right, see the location, it's a large multi-shift medical center. You can see there's a peak reduction there in the morning, which is also when Avista experiences a system peak from heating load in the winter. So we're able to reduce the aggregated average demand during this time by 68% from the baseline level. And then you can see the afternoon peak flattened by about that much too. All right, and then just worth noting here that we did see a difference in the number of sessions that resulted in a fully charged battery in our DR commercial settings. So you can see the fleet location, it had a slight decrease in the battery being fully charged from 78 to 72%. The real difference we noticed was in the workplace location, where the percentage of the time the battery was fully charged when the vehicle was unplugged dropped from 84 to the 42%. So even though we weren't able to interview every driver at that location, conversations with our management didn't mention any dissatisfaction from drivers as a result of this DR. Unfortunately, also, we weren't able to see the final state of charge of the vehicle when it was unplugged. So, you know, just looking into our surveys a bit more, we found 93% of drivers had less than 40-mile round trip commutes. So being plugged in at 1.8 kW for 8 hours would result in about 50 miles of range being added. So we're thinking the batteries were nearly topped off when they were unplugged, when the vehicle was unplugged, but some were still drawing current and weren't flagged as fully charged. So, you know, regardless, it's definitely as workplace DR potentially scales up, that impact should be monitored and definitely explained to both employers and employees. You know, we have pretty short commutes over on this side of the state, but over on the west side, I grew up over there. It's not uncommon for people to have 100-mile round trip commutes. So if you're really relying on that workplace charging to fully charge you, that could cause some issues. All right, so I mentioned that we wanted to quantify the financial costs and benefits of the residential DR solution that we piloted. So we did that. We were able to establish our baseline costs using the baseline profile that we had. So we were able to get the generation T&D costs, as well as our own cost of the energy itself, and then weigh that against the revenue from our baseline usage. So after analyzing that, we found about a $1,200 net benefit to all customers for each EV that we added. Also in this scenario, we assumed the EV lifespan was 10 years in this model. All right, next we changed the charging profile from baseline to the DR profile, and we ran it through the economic model. And what we found was a net benefit increase of about $460, or roughly $50 a year over the 10-year lifespan of the vehicle. It's definitely a positive, as it provides at least a starting point for evaluating the efficacy of long-term DR. But we know from our program the cost of networking, maintaining the stations needs to improve, as well as their reliability, before this becomes a solid solution. All right, so here we have a pretty busy slide, but try to walk you through it. The table on the left here shows a breakdown of the costs and operational metrics for the different types of stations that Avista installed in this pilot on a per port basis. So left to right, we just have installation costs, O&M cost, percent uptime, which we defined as a station being available to dispense a charge, and then the percent online time, which was just the percentage of time station, the EVSE, was connected to a backend server. So while these numbers have actually improved a little bit since the pilot ended, there's still a lot of work to be done, particularly with the online percentage for the residential network station, which were exclusively Wi-Fi. Also, we were able to track the issues in our different stations. We had an interest in that since they were all utility owned. There are plenty of issues, from software integration to just having more robust functions like better watchdogs in their electronics, so that manual power cycling that isn't required to be a solution for these problems so often. So then, if you could go back just really quick, I'm almost done. I just wanted to mention a unique project we did at the end of 2019, where we tested out the interoperability claims on 15 of our stations. So we were able to switch EVSP networks without swapping out the physical stations themselves by working with our new EVSP and a hardware manufacturer. We were able to minimize the amount of time technician would go on site to update the software by doing OTA, or over-the-air updates. Also, as part of this project, we saved our final 2 stations to test out the capability of just completely removing the technician and doing the network switch entirely over the air remotely. So we were able to successfully do that. We're even able to leave in the existing SIM card and just transfer ownership to the new EVSP remotely. So to my knowledge, I think it's pretty cool. I haven't heard of any other utilities doing over-the-air switches like this. I think the project really speaks to the importance of maintaining these open systems and protocols, and then also just having the technical knowledge available to be able to verify claims that vendors present in their products. Okay, that's it for me. So just as a final note, I wanted to let you know that we have a publicly available final report on this pilot project. You can get it on our website or Google it. It's free, so pick it up. So that's it for me, and thanks for listening. You can take questions now if you want.
Great,
Sure,
thank you. All right, let me take a look here. I'm going through the questions. Mike, we have quite a few that came in. We'll try and do some rapid fires here for you. First one is, were Wi-Fi failures due to device failure or customer Wi-Fi issues?
We pretty much narrowed it down to device failure. We were able to test out a few different methods of connecting to the customer's Wi-Fi using different wireless access points and extenders. We had our technicians go out there and actually check signal strength for the Wi-Fi, and everything was within the parameters it should have been for the installation. So we were able to just narrow it down to the actual EVSE hardware.
Okay. The next question, someone asked, did I hear no incentive for opt-in residential DR programs?
Correct. Yeah. So I mean, the customers got an upfront a station for free, and then we also provided a reimbursement to install the electrical circuit. So they got that as a benefit. But as far as a direct benefit for participating and opting into DR events, we didn't do that.
Right. Okay, next question. What type of EV fleets are part of the DR program? Are they mainly company fleets, or do they also have EV buses such as public transportation and other uses?
For this pilot, they were all light duty vehicle fleets. And yeah, we're looking on expanding that in our future transportation electrification programs.
Thank you. Next question. Does O&M costs include data management fees from third-party charging providers?
Yes.
Okay, great. I think Dan, we are definitely going to get to you. I just want to ask a couple more questions here. Mike, this one's for you. Are any Tesla owners participating in Avista study? The question person who's asking remarks, one of our utilities has reported a challenge with participation by Tesla owners in our EV pilot, largely due to charger communication issues and Tesla's proprietary data.
Yeah, we do have customers participating with Teslas. It's probably about 25% of our makeup, just off the top of my head. I haven't heard of that issue. We were just, pulling the data straight off of the station. So if they're trying to connect using like Tesla's API to get the data directly from the vehicles, there might be issues with that.
Great, thank you.
Okay, so moving now to Dan. Again, there might be time at the end for additional questions. So Dan Barrowmester from EPRI.
Wonderful. Good afternoon, everyone. Dan Barrowmester from EPRI. Thank you very much for having me today. Just to follow up maybe on that Tesla question. So we just finished up a nationwide Tesla data collection and analysis where we looked at Tesla drivers, where they go, where they charge, how much do they charge, that sort of thing, all protecting their privacy. And yeah, it did go through their their data, the data portal, their API, and it was done with their knowledge. We briefed Tesla, although they didn't support it, so they're completely neutral on the project. So yeah, there's different ways to get this data, and data helps us all as an industry make decisions. So I am gonna talk about vehicle to grid and vehicle grid integration here. Before that, I thought we'd talk briefly about the market just to kind of give context. And when I think about this, the kind of the first thing in my head is I kind of divide the EV customers into two buckets. We have the individual, all of us as individual consumers, and then we have the fleets. And for us as individual consumers, there's a huge, there's an emotional connection to our cars, whether it's big or small. But there is some kind of emotional connection. So that's important to keep in mind whenever we talk about programs or policies or technologies or that sort of thing. And then for the fleets on the commercial industrial side, is they all have a job to do. As long as the technology works and it's more cost effective, they look at total cost of ownership. The fleet managers are up for it. But again, that's if their job is to deliver the mail or deliver cola or to taxi people around or what have you, that's their first priority. Any kind of grid interaction would be further down the list. So just ask us all to keep in mind when we go through this. All right, next slide, please. So EPRI, we don't do policy. We just jump through it. So there's a dichotomy in the world, or in the world of electric vehicles. So first of all, it's a global market. It's all about scale on the next slide. And as you can see here, and this is data through the end of 2019, the U.S. is basically in third place behind China as the world's largest car market, also the world's largest EV market, and then the EU is also growing as well. I will say the 2018 numbers are largely distorted in the U.S. by the launch of the Tesla Model 3, so it's important. A better slide would be actually one looking at kind of a 10-year growth rate rather than this 2-year snapshot. And obviously, with the COVID virus and the resulting economic downturn, there are more questions than ever. There was one earlier about how has this impacted launches of vehicles. I'll talk about that in a second, but basically the short answer is we're already seeing delays for gasoline vehicles as well as electric vehicles. In fact, just a few minutes ago, I saw a note saying that Ford Motor Company was going to develop an all-electric Lincoln badged SUV off the Rivian platform, and that's been canceled allegedly due to the virus. So anyway, we're seeing stuff here. So the important thing to remember is that, as global as this market is, it's decisions made locally. So whether that's us individually or the fleet managers, someone has to decide to buy this car. So the vehicle has to exist. Car dealers have to stock it, and then customers need to know all about it. They have to like it. Can they afford it? That sort of thing. The affordability piece is a bit interesting. I mean, if you click every box on one of the big full-size truck from Chevy or Ford, you can get north of 70 grand. And then there's financing out there for like 84 months. So I'm definitely not recommending that. But my point is, like, the affordability piece is a bit kind of squishy to me. I think even further upstream is, like, if someone wants an SUV and they're open to getting a plug-in SUV, like, that has to exist. Or similarly, if there's like, look at the post office, if they want an electric delivery van, one has to exist that meets their specs, that sort of thing. And then, the wild card on top of all this is, like, what does this mean with the recession? And because it's this double hit, which is different than last time, 10-ish years ago, is we have a supply issue, supply challenges and demand challenges. There's the supply of vehicles, big and small, and then there's the demand of each of us with our own, what's our household budgets or our company's budgets. There's just a lot of questions today. And then, the last piece when it comes down to this local decision is, one of the problems in the market today, and the good news is this will change in the next, 18, 24 months, is like, if you look at the list of 25 best-selling cars in the U.S., first of all, most of those aren't cars, they're trucks, SUVs, crossovers. There's only one, the Ford Fusion, that has a plug-in option today. So that is, a current challenge for the market. So let's go to the next slide, please. So where are sales? So this is a rolling 12-month average. Back in 2019, looks at it on a county-by-county basis. Each of those kind of funny boxes is a subset of data. We'll look at one of them. And I think the highlight here is that, EV sales on a county basis range from 0, that's the black, all the way to north of 20%, and that's the yellow. And to me, when we look at these trends, there's a couple of things that emerge. Now, you can see the Z states, which are highlighted in blue, or, Colorado's dotted in the process. Got to add Washington. Is that we're starting to see pockets emerge beyond what one might think are the early, either the early adopter markets or the areas that have strong, kind of zero emissions policies. And what we mean by that is, we can't see it on the slide, but if you flip through the data from, say, the last 6 to 12 months, we're starting to see pockets emerge in the Rockies and the central south, southeast, Midwest. So it's, we're starting to see, again, it's low numbers, and it takes, 17 years for the U.S. car fleet to turn over, but, we're starting to see pockets emerge. And again, when we get to that scale, this kind of goes back to the vehicle grid integration. Like, I can't wait till we have that problem with vehicle grid integration. We've seen some great work by Avista. We've seen some great work by others. There's global pilots that go along around the world about how to do this from a technical perspective. But at the end of the day, utilities, whether it's the advent of air conditioners or electrification of society in general, they're good at, like, upgrading for the grid. The question, at least one of the questions in my head, is less of a technical one, is like, how do we make it easy for the customers, worthwhile for the customers, whether they're the ones with the actual electric device or not, and then to kind of the benefit of all. So let's take a look, deep dive into kind of a couple states. The next slide. So just looking at the West Coast, we heard from Avista. This is why I chose them for this presentation. So we have, Washington, Oregon, California, and each bar, each vertical is a different county. And the takeaway here is that it's not, you can see the national average is right below 2%, and then the regional average for these 3 states is 6.8%, but you can see it really varies county to county. And again, if you start to look into the demographics of some of these counties, and I say this because I come from a fairly low-income county myself, it's like these lower to middle-income counties are starting to have stronger and stronger market shares of EVs, which to me is encouraging, because again, it's going beyond call it the early adopter / welfare counties. I mean, let's face it, not every county is going to be that one there in California that's north of 20%. Next, please. So something just as a reference that might be useful for you and your stakeholders. EPRI just released this a few weeks ago. It's our annual guide to EVs. A couple of things. There's going to be, so this is available online. It's basically a nice PDF, but we're actually working on both a smartphone version as well as a web version. It's free, available to everybody. We also just translated it into Latin American Spanish. Now, granted, it's what's available in the U.S. car market, but again, there's 40-some-odd% of the people in the U.S. speak Spanish as their first or second language, so we just thought that would be an improvement, usable. And then, the second thing here, and this goes back to, again, the scale, is on the upper right, you look out to 2022, and not only are there north of 120 EVs that are going to be announced, and again, this graph might shift given the current virus, but that big blue section at the top, that's SUVs and crossovers, and that's what the market is buying today. The market, the U.S. car market, and this is all vehicles, plug-in and gas and diesel, is more than 60% SUVs and crossovers, and in places it's 70. So the more options we give customers, the better. All right, next slide, please. And here's some that were announced to come later this year, early next year. The Rivians have been delayed. Ford has announced that the Mach-E's been slightly delayed. Again, we're talking months here, not years. No news on the Jeep or the Ford Escape or the Toyota RAV4, but these are some of the ones that are coming. It's important to note that, for example, the Toyota RAV4. So the RAV4 is Toyota's best-selling car in the U.S. Sells more than the Corolla, more than the Camry. So the fact they're going to have a plug-in version, it's rated at 39 miles. For plug-in hybrid, that's a great thing for customers. And again, kind of gets to that scale of the vehicle-grade integration. Next slide, please. So let's talk about charging. So a lot of you have probably seen this EPRI pyramid. Mark Duvall, our director, created this back in 2007. And basically the hypothesis is that, for those of you who aren't familiar with it, is that 70 to 80% is going to happen at home. Caveat, if you have a place to charge overnight. And then another 15% at work. And then, the public kind of depends on what's going on, but call it 5 to 10%. You can see some data from an SRP report that's linked below on what we have out there. Every light duty individual EV is roughly 2,800 kilowatts per EV per year. Again, there's a spectrum there. Are you a high mileage user in an aggressive climate, or are you a low mileage driver in a mild climate? That really depends. But the point is, there's kilowatt hours here. But at the end of the day, at home, it's largely a hair dryer or a big air conditioner. But there's still work to be done. Next slide, please. So you can see this is the latest summary of the North American utilities. Now, there's roughly 4 major efforts going on for EV charging infrastructure, and the utility one is just one of them. So there's the Tesla work, there's the taxpayer money that's been put into the market for the last 10, 11 years, and then there's private capital that's gone in across America. And here's the kind of the quick snapshot of what's going on across North America. Now, some of these are the utility owns and operates the charging station. We just heard from Avista, and then some of these are more the utility owns and operates up to the the actual charging pad. Every jurisdiction is gonna kind of work out that last 10 feet for themselves. But the point is, it's like there's a major, it's kind of like 4 legs of the table. There's major efforts being going on by many stakeholders, not just utilities. And I think one of the key challenges I can say as the EV driver, and there's surveys on this, is when you use public charging, if you're going to grandma's house over Thanksgiving, or if you're out running errands on the Saturday before Christmas and you want to go to the next town over for dinner or what have you, or to do more shopping, that's when public charging really matters, let alone the public safety. So the public, not only the existence of it, but is it accessible, is it clean, is it well lit, is it safe, all those kind of things. We've learned over the last decade or so that how that piece, the ongoing operations and maintenance, how that piece is treated really makes a difference when it comes to the availability and kind of functionality for public charging. All right, next slide, please. And here's what it looks like right now. So this is all from we get this data from our friends at PlugShare. It's a variety of networks, which is good, a variety of business models. One of the challenges that is being worked on right now is some of these networks require different fobs or apps or what have you. And that's for, just to get the station to turn on and charge your driver, as well as on the payment side. To their credit, the private charging station companies understand this challenge and are working on I kind of think of it as it's like long distance used to be. I'm old enough to remember long distance charges on the back of your local phone bill. So they're trying to figure out that piece of it as well. So expect to see consolidation here, maybe not with the brands, but more at least on the kind of the use and operate. It's like our ATM cards today. I think we can each remember when you had to find the right ATM that matched your network if you were out of town. And now today, it feels like, I'm sure there's probably different, but it seems like nearly every ATM card or even credit card works in nearly every ATM around the world. So we'll get there. All right, next slide, please. So now we're talking about DC charging. So this is, everything from the Tesla supercharger all the way up to the charging plazas to, the transit buses, all that sort of stuff. So kind of falls into 2 buckets. On the light duty side, you know, the market's between 100, it's right around 150 to 250 kilowatts per vehicle DC. And then, you know, I was presenting this morning in the high power charging world. Now the vehicle manufacturers are working on a standard that goes up to 4.5 megawatts per electric truck. I'm not trying to scare anyone. That's not going to happen anytime soon. And the stakeholders understand that, like, well, if you put in 10 of those, that's 45 megawatts. Call it, 5 megawatts for a buffer. You're looking at a 50 megawatt charging plaza. What does that look like from a utility perspective? What are the costs? What are the timing? That sort of thing. So there's this balance right now between, what does, company X's fleet need to get their job done, and the charging levels to make that happen versus, what are the kind of consequences on the grid side for that. These high power charging plazas, whether it's a travel plaza on the interstate or a distribution center or a bus transit depot, they're not going to be a surprise, right? We're all not going to wake up tomorrow morning and, oh, there one is. Like, there's going to be plenty. But the question in my head is a combination of kind of three things: the technical challenges, which I would say is probably the least of our challenges, and then the next two are based off kind of current policies or standards or operating procedures. Like, how long does it take to put in a large high power charging plaza, and then how are the costs allocated? How much does the actual distribution company pay versus how much is shared amongst all of us as the rate paying customers? And that's something that the entire industry is looking at, stakeholders are looking at. I can remember when I used to work at a utility, we'd get calls from the private natural gas vehicle fueling station companies. They want to know where on the pipeline did we have pressure for a fueling station, how long would it take to get, the ones that didn't, how long would it take, and how much would it cost to get up to that standard. So there's ongoing issues here with the vehicles. So and the charging sites, but again, it's at this point it's largely known. There's always the question of what's not known. Next slide, please. So here come the really big ones. Louisville, Kentucky, they have, up in the upper left, they have buses running around. I'm sure people have heard about or seen demonstrations of the 16,000 electric buses in China, the 12,000 taxis. There's, Freightliner up in division of Daimler is demonstrating in Southern California, as is Volvo trucks, some, electric box trucks, there's electric school buses. This is really a global phenomena. For a variety of reasons, part on the environment climate side and part on the cost effective side. So, there's about 3 dozen use cases, big vehicles, of various shapes and sizes, but, transit buses and that sort of thing are probably the furthest ahead. And then you kind of go from there about what's in demonstration mode and further behind. Next, please. So the next set of slides are more for you and your staff later to kind of review. But I didn't want to kind of flag, there's kind of two sets of slides here. If we take the example of a school bus, and the school bus is often used because it's a large vehicle with a big battery that has both daily and seasonal peaks and valleys. Runs in and out for a couple hours in the morning, runs out for a couple hours in the evening, and then, summertime's a lot different than the school year. So there's some questions. I took a typical school bus project, and over the next few slides, and we'll just flip through them. But I kind of circled the ones that are the most important when we're thinking about vehicle to grid. And then there's two slides on kind of the light duty managed charging side. So let's go to the next slide. And I think we'll just kind of, in the interest of time, let's go to the next one, skip through these. But these are some of the questions that in the categories that come out in a vehicle to grid school bus pilot. Next slide, please. And batteries, battery degradation, going back 10 years ago, there was a question like, well, what if you actually take power out of the battery and put it back, whether on a local building or back on the grid, like what does that do to the batteries? At the end of the day, the car companies or the bus company has to warranty the battery. And what we've seen so far is that the batteries, aside from perhaps one type of technology, last extraordinarily well. Seeing very few failures of the batteries. Lithium ion is a great, it's always a great technology, but then unlike in our phones and laptops, there's active cooling. So basically the batteries are managed, they're kept at a nice warm, comfy temperature. Batteries are like us humans. They 70 degrees-ish, plus or minus 50 degrees. But that is a major question, is it worth, at the end, it's cost and benefit. So in the category cost, like what's the impact on the batteries? The early testing we've seen, again, for vehicles big and small, show low degradation of the batteries, especially since when we think about vehicle to grid, actual power coming off the battery is only one of the options that the vehicle can do. All right, next slide, please. I circled customer satisfaction because I think this often gets overlooked, and all of these points are important. Anyone, mentioned this at the beginning, but I don't know if you've ever rented a car, or even your own car, and you've walked out to a shopping mall parking lot or something, and someone, total honest mistake, is like trying to get into your car. They also might have a, whatever, that you have a blue Toyota Camry, and they're getting in their blue Toyota Camry, unfortunately, is also yours. Like, most of us have like emotional reactions to that kind of stuff. So there's this idea of like, oh, you touching my car, what are you doing to it, let alone any kind of like cost impact. So my point is, with this slide, there's a variety of customer impact pieces that go along with all this. So let's go to the next slide and probably just skip through this one. Again, these are important research questions, but a bit kind of a degree or two removed from vehicle to grid itself. So let's go through. But again, I wanted to the reason why I include them is, again, for you and your staff later. So if you want to look at them and kind of see what the major questions are, because it's a holistic. It's not vehicle to grid or managed charging in a vacuum. It's a variety of things. Let's go to the next slide, please. Distribution system. So this gets into the nuts and bolts. There's a question earlier about distribution system upgrades for whether it's one-way or two-way power flow, and that's at the end of the day, that's a major question. I mean, on the benefit side, there's stuff on the wholesale side of the market, the ancillary services and the frequency regulation and all that kind of stuff on the wholesale side of the market, and that's stronger in some parts of the country rather than others. But the part that is common across most of the country is everybody has a distribution grid. And can any kind of managed charging be used to help delay to upgrade the transformer or the substation or the wires or what have you? And then there's an established process for what rate cases are similar on how utilities do all that or incentivized to do all that. So I think, to me anyway, like as we're kind of looking at this, that's probably one key area to look at is if the distribution infrastructure can be delayed, to what extent, and then what does that mean for, again, costs and benefits and how it's all shared. And again, EPRI doesn't have a role in saying what's right or wrong there, but that's, from a technical side, that's one of the major questions. Next one, please. So on the transmission side, kind of talked about all this. All right, next one, please. And then, at the end of the day, there's going to be a stack of costs and a stack of benefits. How does that overlap versus the customer needs? And if you're thinking about like a seesaw, I have 3 young kids in the age of 7, so we go to the park a lot. They love the seesaw. Like, do the benefits outweigh the costs? And that's a lot of the questions. Whether the vehicles are big or small. So now, if we go to the next slide, I'll have just 2 quick slides on the light duty kind of vehicle grid integration work. When we heard during the Avista presentation, there's various ways to kind of talk in between the vehicle, the charging station, and the grid, and the various players on the grid. And right now, one of the it's like a logistical challenge is how do you talk between the dozen or so car companies and the 3,300 utilities. One solution is to go through the charging station. That requires cybersecurity and a network connection. There are issues with all types of communication. I mean, I think we've all had dropped calls. We've all had Wi-Fi kind of come in and out. Like, as robust as communication is, and it's getting better too, it's not 100%. So that's always a challenge regardless of what path. There's cybersecurity issues with all these different paths. One project that EPRI and the utilities and the car companies have been working on for the last nearly decade now is trying to do a platform in the sky called this Open Vehicle Grid Integration Platform. I told the project manager they should call it the free pizza and beer, because that's a lot easier for me anyway to remember than Open Vehicle Grid Integration Platform, but here we are. And you can see there's 5 major automakers, and there's 3 more who are observing, and then there's more than a dozen utilities. And they're trying these different use cases to figure out whether it's V1G or V2G, what's the right way to do this, and how can the grid benefit, and how can customers on all sides of this kind of ecosystem benefit, not just those who participate, but the neighbors next door. Next slide, please. So these questions have to do with one-way and two-way power flow. There's a myriad of stakeholders and questions, and again, we do want to obviously minimize impact on the grid and minimize cost to the grid and all that kind of stuff. But at the end of the day, whether it's the fleet with a job to do or the customers who have a place they want to go to with a minimal fuss, like that customer piece is also equally important. Sometimes gets skipped over. And that's one of the things that not just the open vehicle grid integration platform, but a lot of these pilots you see around the world are really looking at. But at the end of the day, and it's why I had this presentation at the beginning, this is all about scale. You know, if you have a couple cars hanging off a transformer, it's not that big of a deal. At home, the charge rate's relatively low. But as we think kind of out to the future, you know, what do we need to be doing now to help kind of make sure, you know, be going to where the puck is going, right? When it comes to making sure the technology and programs are there. And that's what these pilots get to. All right. So maybe last slide. Lessons learned. Just wanted to highlight maybe a couple of these. And, you know, the importance of customer choice. I can't stress this enough. I mean, right now, you know, there's basically like 2 or 3 plug-in electric crossovers or SUVs that customers can get, and that's just not representative of what customers are buying. Positive news that these are coming over the next, you know, 2 months, or excuse me, 2 years, and that, you know, sometimes for customers, you know, the charging can be as simple as plugging into a new wall outlet in the garage. There's a lot of attention and hype and dollars that are, or not just dollars, but global money that's going into autonomous driving. It's extremely challenging, and no one quite knows how that's going to sort out. The technology is robust, it's getting better. Batteries are robust and getting more inexpensive. And, you know, most important to everyone on this phone, like the impact of policy and incentives and programs is such a huge component, such a huge pillar of this entire industry. So can't thank you enough for all of your hard work on that. And to close, maybe with the last slide, is there's just a lot of unknown in the future. Nobody knows. Took this around the corner from our house. Nobody knows quite what the future is going to look like. But it's going to take, I think, all of the players to kind of make this happen. So with that, I'll stop talking and thank you for your time. Happy to take questions now or later, whatever's useful.
Dan, Commissioner Bocanegra here. Thank you. I will go through some of these questions. I hope that you guys don't mind going a little bit over. We have quite a few questions, and I definitely want to get to all of everybody's questions. So, Dan, one question is, does pursuing V2G void the battery warranty?
So right now, Nissan, what comes to mind is Nissan in Japan allows this. In fact, they designed a charging station to do this. No other car maker that I know of of the light duty vehicles has actually allowed vehicle, maybe Mitsubishi, but and that's largely because there's a Japanese home market push for actual vehicle to grid. The managed charging, the one-way power flow, everyone can do it, but the two-way power flow, it's, as far as I know, it's just Mitsubishi and Nissan.
Great, thank you. Let me go through the questions here. We had a few come in earlier, and then we'll circle back to you, Dan. So this question is another question for Ryan or for the others. Given the potential for rapid adoption of EVs as demonstrated by the historical adoption curves Ryan showed, what are his recommendations about considering high EV adoption when developing utility distribution plans? Is it recommended or necessary to do so at the current EV adoption rates?
Yeah, I'm happy for others to chime in. You know, I think my very basic thinking about that is it's really hard to predict EV adoption even over the next few years, let alone over the next decade or so. And if you just look at the range of EV adoption forecasts that are out there, the differences are pretty dramatic depending on where you're looking. I think, you know, personally, given the potential for adoption to take off, particularly given what Dan was just saying about model availability that's hopefully going to appear over the next couple of years, to me that calls at least for the need for some scenario-based planning where the potential for increased EV adoption should be considered as a scenario, even if it is not currently part of the utility's core distribution planning case. Because I think it's, you know, the potential impacts of EV adoption really rapidly taking off are probably just too great to ignore, even if it doesn't, where we sit today, feel like this is something that's imminent. And maybe even, you know, simple exercises along the lines of what we heard in the Avista presentation around just some basic scenarios around, you know, overloading transformers associated with varying degrees of adoption. Even that will help us to at least sort of make this problem tangible and then start to be able to anticipate when some really serious action will need to be taken.
Thank you. Question posed, I think, for any of the panelists. Have you come across any data or studies that looked at or compared customer dollar savings under active or passive managed charging?
So
Yeah,
this is Dan from EPRI. There's,
go ahead, Dan.
I was just gonna say there's a few reports. Pepco out in the greater Washington D.C. area has done a few studies on this. They also had like in addition to that, they had so they did customer savings on and off a time of use rate. They also did added in a green tariff for, so basically, green generation and kind of did the take rate on that. So that's one that comes.
Yeah, and in our final pilot project report, we didn't compare the cost savings, but we actually just compared the percentage of load shifted from I think it was DTE Energy and I think it was Pepco as well. Just comparing those versus managed charging solution like ours. I don't have that on hand right now. It's in the report though.
All right, we have an audience member with their hand raised. Before I get to her, there's two more questions for Mike that were previously asked. The first one was, does the commercial L2 installation cost include equipment costs?
Yeah, including the EVSE.
Okay, and the next question for you, Mike, was what caused 9 chargers from being network connected?
I'm sorry, could you repeat that?
It might be worded a little, it says, what caused 9 chargers from being network connected? I think I'm going to guess here for the audience member, but I recall, I think there was a slide earlier where you said that 9 of the public chargers maybe were
right.
connected. I think they're asking, why did you not connect those?
It was a decision just really based on the location and working with the site host and, determining if they needed to be able to charge a fee for usage and if they were interested in getting the data. We just decided to install non-network stations as well to get an idea of the difference in costs, both installation wise and long-term operations, to compare between networked and non-networked too.
Okay, thanks, Mike. All right, I'm going to turn it over to Danielle and Charles. On my end, I cannot see the hand raised, so I'll let you guys try and tackle that one. Thanks.
Sure. So here, it looks like I'm not seeing the hand raised anymore, but Kristen Klingan, I guess you were unmuted. I think you were the one who raised your hand before if you have a question. Go ahead, Kristen. Okay, I cannot hear you, unfortunately. So I guess type your question in the question box if you can. Thanks.
While we're waiting for Kristen, Charles, I had a question. I think I always try and prepare questions in case there are none, but I guess the biggest question I had, reviewing for all of this, what are the differences in data collection capabilities between when a utility is doing the managed charging versus a third party? I guess, who's in the best position to get all that data and make use of it, if anybody wants to try and tackle that.
Yeah, well, I can just say from working with the EVSPs, the electric vehicle service providers, so the software providers, they are they're way more advanced than the utilities are with being able to collect the data and just provide information from the stations. Down the road, we're installing AMI meters here in Avista service territory, so we'll have some more options, especially if when we can disaggregate the load. But I would say just for charger specific energy information, and then also just information on like diagnostics for the chargers, the software service providers have, I mean, they're the ones to go to in that position. I don't know if that answers the question.
No, that's great.
Yeah,
Thank
and I would just, this is Dan, so I would just add to that too. It's like only the customer knows what the customer wants, and only the car knows the state of the charge of the battery. So no matter how smart the station is or the meter is or anything else along the chain, back-end processing, it all, I mean, those two inputs are needed for any kind of, you know, program or analysis or what have you.
Thanks, guys. I'll turn it back to Charles and Danielle.
Okay, thanks everyone. It's 4:30 now, so unfortunately no time for our discussion questions this week.